Welcome to Study Loop.
So there are actually 4 small questions for this big question. So firstly, we will answer the first question. Should the government impose taxes on sailors or consumers? The answer is actually no matter which side will be burdened by taxes from government, the sailors and consumers will share the taxes in the end. I will give 2 graphs to understand what happened after taxes for consumers and sailors. So now we have horizontal axis quantity for ice cream cone and vertical axis price for ice cream cone. And we also have 2 curves, the demand curve and supply curve for ice cream cone as a market. And we know the demand curve and supply curve will intersect at one point. We assume this point is A. In this market, the point A is actually equilibrium point, and we also can get the equilibrium quantity 100 and the equilibrium price $3. So this is the ice cream cone market before taxes. But what happens if there is taxes on sailors? If government decided to put taxes on sailors, sailors will think it's not that profitable compared to before without taxes to sell ice cream cone. So the sailors will decide to sell less than before. So the supply curve will move to the left side. And in this graph, we will move to the new supply curve as 1. After we shift the demand curve to supply curve to the left side, we will get a new equilibrium point B here. And we also will get new equilibrium quantity now to 90 and new equilibrium price 3.3. So now we will analyze what happened for sailors and consumers after taxes. So for sailors, before taxes, the equilibrium price is $3. So sailors can get $3 for selling 1 ice cream cone, and the consumer can have to pay $3 for buying 1 ice cream cone. So for sailors, the price is $3 before taxes. And now we have taxes for sailors, 50 cents for each ice cream cone. So what's our price for sailors? For each ice cream cone after taxes? After taxes, we can see the equilibrium price is 3.3. And for each ice cream cone, the price should be $3.3. But for sailors, they actually can only get 3.3 minus 0.5 is equal to $2.8 after taxes, because this 50 cents will be put in the government pocket. So the sailors can only get 2.8 for each ice cream cone. So now we can see after taxes, the sailor can only get $2.8, but before taxes, the sailor can get $3. So actually, after taxes, the sailors get less for each ice cream cone. So 3 minus 2.8 is equal to 0.20. So for each ice cream cone after taxes, sellers can get 20 cents less than before without taxes. So this is what happened to sellers. But what happened to consumers? So before taxes, the consumers has to pay $3 for buying one ice cream cone. After taxes, the equilibrium price is 3.3, so consumers have to pay $3.3 for buying one ice cream cone. So for consumers, they actually pay more than before without taxes. 3.3 minus 3 is equal to 0.3. So after taxes, consumers have to pay 30 cents more to buy the same ice cream cone. So this is what happened for consumers and sellers when we put taxes on sellers. Now, what happened if we put taxes on consumers? So we still will use the graph to understand. So the horizontal axis is still quantity and price. The vertical axis is still price. And we have demand curve, supply curve, and we have equilibrium point A, and we have equilibrium quantity 100, and equilibrium price 3. It's actually same with the answer with the graph in first question before taxes. But now we have to put taxes on sellers. So sellers will think, oh, it's a little bit more expensive to buy the same ice cream cone, so the sellers will buy less. So we will shift the demand curve to the left side rather than the supply curve in the first question. So now we will get the new equilibrium point B in this market and the new equilibrium quantity 90 and the new equilibrium price 2.8 in this market. So what happened to consumers and the sellers? Firstly, we will analyze what happened to sellers. For sellers, before taxes, they will get $3 for each ice cream cone. But after taxes, we can see the equilibrium price is 2.8. So the sellers can only get 2.8 for each ice cream cone. So for sellers, they will make less. For each ice cream cone, sellers will make 20 cents less than before. So what about the consumers? For consumers, before taxes, they have to pay $3 to buy one ice cream cone. But we have to remember that we put taxes on consumers, so they have to pay extra 50 cents for taxes. So after taxes, they actually need to pay $3.3 for each ice cream cone. Why they have to pay $3.3? Because after taxes, the equilibrium price is 2.8. So the sellers will ask for 2.8 for this ice cream cone for every consumer. But the consumer will pay 2.8 for sellers, but also they need to pay 50 cents to government. So for consumers, they need to pay 2.8 plus 50 cents. It's actually $3.3 for each ice cream cone. So before taxes, consumer only need to pay $3, but now they need to pay $3.3. They actually paid more. 3.3 minus 3 is equal to 0.3. For every ice cream cone, consumer have to pay extra 30 cents to buy the same ice cream cone. So for the first case, we put the taxes on sellers. We can see the vertical distance from B to C is actually the taxes, 0.50 cents. So this distance will be taxes on sellers. And from 2.8 to 3, this 20 cents will be burdened by sellers. And from 3 to $3.3, this 30 cents will be burdened by consumers. So if we put taxes on sellers, actually sellers and consumers will share the burden of taxes. So in the second case, we put taxes on sellers. Put taxes on consumers, I'm sorry. And we can see here in this graph, the vertical distance from B to C is still the tax for consumers. From 2.8 to 3, this 20 cents will be burdened by sellers, and this from 3 to 3.3, this 30 cents will be burdened by consumers. So in this case, the consumer and sellers will share the burden of taxes. So taxes. So for the first question, no matter which side will be burdened by taxes, the consumer and sellers will share the taxes in the end. For the second question, the demand of gasoline were more elastic. There is more effective in reducing the quantity or less ineffective in reducing the quantity. The answer is there is more effective in reducing the quantity. There is quantity and price and demand curve. It's 1, 2, 3. Yeah, this is 1, 2, 3. So for this demand curve, there are 2 points, point A and point B. At point A, the price is $2. At point B, the price is $3. So now we have to increase the price from $2 to $3. So we can see we will move from point A to point B along the demand curve. What happened to quantity? For point A, the quantity is about 3.2. For the point B, the quantity is about 22.5. So if we move the point from point A to point B along the demand curve, we will see the quantity will decrease from 3.2 to 2.5. Its point is 30. So the quantity will decrease by 0.7. Now we have another more elastic demand curve. D2. So it's the same vertical and horizontal axis. We also have the same point A, and point B. So now we do the same thing. We increase the price from $2 to $3. We will see we have to move the point from A to B along the demand curve. And the quantity will be reduced. At point A, the quantity is 2.5. At the point B, the quantity is 0.9. So if we increase the price from $2 to $3, the quantity will be decreased from 2.5 to 0.9. Is equal to 1.6. From these two cases, D2 demand curve, the second demand curve, D2, is more elastic than the first demand curve. And if we increase the same amount for price, $1, we will see for the more elastic demand curve, the quantity will be reduced more. So if the demand of gasoline were more elastic, there will be more effective in reducing the quantity of gasoline consumed. If we just answer this question by theory, we have to understand more about what is the elastic demand. The elastic demand is actually means the change of quantity will be more sensitive to the change of price. So for example, if I increase the price for $1, the quantity will be decreased by 100, 1,000, even 10,000, 100,000. It means this demand is more elastic. So if the demand of gasoline were more elastic, after the price change, the quantity will be changed a lot. So there is more effective in reducing the quantity of gasoline consumed. Now we will answer the question 3. Are consumers helped or hurt? In this question, we have to go back to the graphs in first question. In the first question, we know for consumers before taxes, they have to pay $3 for each ice cream cone. After taxes, they have to pay 3.3. So they need to pay extra 30 cents. So for consumers, it's actually worsen off because they have to pay more for buying the same stuff or same good. That's the question, are workers helped or hurt? So now we go back to sailors. Before taxes, they can get $3 for each ice cream cone, but after taxes, they only can get $2.8 for every ice cream cone. So they make 20 cents less. compared with before without taxes. So actually for sailors, they also wasn't off.